Hello, this video I'll explain the first question is about average rate of reaction. Okay, so for average rate of reaction, and then we suppose firstly we should know this core information if we will have a generic equation such as A, B are the reactants, produce C and D. Okay, and this lowercase a, B, C, D are the coefficients. Okay, so of course how the reaction happens in mole ratio between reactants and products. Okay, and then the rate of the reaction can be expressed by any reactant or product. Okay, so then they have this equal relationship, and then in the another perspective is that either use any reactant such as A or B, or use any of the products C or D. When you use any of these reactants or products to express the rate of reaction, it should always equal the same rate of the reaction, because again, rate of one reaction should be just right one number. Okay, so then that's the idea. So then therefore we should know this. If it's reactants, we should use the negative sign 1 over the coefficients multiply change in concentration of A over certain time interval, which is delta T. Okay, the reason why we have to add a negative sign, as explained, because the change in concentration of a reactant as time goes on, this will be a negative value because the concentration of reactant will decrease. Okay, so and therefore, overall, by incorporating a negative sign, will ensure the overall rate of the reaction will end up with a positive value. Okay, so then that's the idea. Now, of course, this also equals to, we can use the reactant B, same idea, 1 over B. B is a coefficient for B, and change in concentration of B, we use bracket to express that, and change in certain time interval, delta T. Okay, and of course, this also will equals to this all equal signs, right? Okay, so now equals to product. Okay, so since product as the reaction goes on, right, it's gonna make more and more in products. Okay, so then it's going to be positive. So therefore, that will be positive 1 over C delta C over delta T. This also equals, so of course, I can use the second product, which is D in this case, 1 over D coefficient, change in concentration of D over delta T. Okay, so then this is the rate of reaction. As I mentioned, you can use any reactant or product to express the same information. Okay, so now this question, particular question we're looking into, is based off this reaction. Okay, so then the coefficients are right here. Okay, so there's nothing means it's 1, right? Okay, so now that's really the question. Okay, so the question is saying if the concentration of HI, which is our reactants, okay, changes at a rate of 0.45 molar per second. Okay, so now I'm going to try to express this sentence with expressions like we did earlier as such, right? Okay, so then this sentence can be translated into such expression. Okay, so this sentence saying how fast, right, the concentration of HI, how my reactant is changing. Okay, so this is how reactant is changing. At this moment, we're not associating that information with the overall reaction. So we're simply saying how fast this reactant is being consumed. Okay, so then therefore, to express that overall, since we're expressing a rate, we still want it to be a positive value. So then the rate of disappearance of HI can be expressed. Okay, so since it needs to be set as a positive value, so I have the negative sign, and the change in concentration of HI over certain time interval, right? Simply, right, this is definition as rate, right? Okay, so changing in concentration over certain time interval. Okay, so then I'm simply express what it is, and of course have a negative sign. Okay, so now this actually equals to 0.45 molar per second. Okay, so this information equals to that, and now let's see what the question is asking us to solve. Okay, so it's asking us to find out the rate of appearance of I2, which is the product. Okay, so similar idea, the rate of appearance or formation, whatever wording, right? Okay, so it's the same idea, right? Okay, so this will be, of course, positive. How fast we can make the product. Okay, how fast, again, the rate of something we always use, right? The change in concentration over change in time. Okay, so now you see what we need to look for and what's given. And now the question is, how can we associate these two information? This expression over here, and this is something we wanted to look for. Okay, how are they connected? Okay, how are they connected? As I reviewed earlier, you probably thought of, okay, I know how reactants and products associate with my overall reaction by those coefficients. Now I can do that for my particular reaction right over here right now. Okay, so now we're going to do that based on the given equation. Okay, so we know the rate of the overall reaction I can use as my reactant to express it. Then that will be negative 1/2 delta HI over delta T, right? Okay, so now we need to incorporate this half again, because now we're not expressing just how fast, right? The rate of disappearance of my reactant, I want to express the rate of reaction. The relationship is reflected by incorporating this coefficient, okay? And then therefore, we also know, right? Again, we care about the product, okay? So this also equals to positive delta I2 over delta T. Of course, we want to incorporate the coefficient as well, but numerically, right, it's the same thing because the coefficient is 1. Okay, so now we know these two information will equal to each other. From the question, we know this piece, right, that's over here, that equals to a certain value, and we are looking for the other piece over here. Okay, so now I believe we can plug in the info. Okay, so just one more time, we recognize, okay, over here, there's this expression, and that expression equals to what? The expression equals to 0.45, right? Okay, so 0.45 molar per second multiplied 1/2, right? Okay, coefficient now needs to be in play, right? Okay, so then this just simply equals to this expression, okay, and then of course that's what we're looking for, and then therefore the answer for this question will be just C 0.23 molar per second. Okay, so this is how you solve this question, but I just want to add on, right? Okay, again, for this question, very simple, math-wise, came out nicely as well. Okay, I'm just making things up. What if over here, okay, the coefficient, I know for this question, for this balanced equation, it is 1, but I just want to make things up. What if this wasn't 1? What if it's a 3? We should know we're still looking for, what we're looking for doesn't change, but we just have a coefficients over there. We need to handle it. So mathematically, how we handle that, if you have a 3 on the denominator, in order to get rid of it, what do? I'm going to rewrite over here. Okay. So on top of this step of calculation, right now, we just need to, since we need to get rid of 3 on both sides, then I just need to multiply 3, right, on both sides. Okay, so if there's a coefficients, and that's gonna how you handle that piece, and therefore still, right, finding what we needed to. Okay, so anyways, the last piece, just me adding on a piece of information to help you to think about it, really understand what's going on. Then other than that, this is a question about average rate of a reaction regarding the reactants and products, how they're related, and then that's that. And hopefully this is helpful. Thank you for